Hello students, I am Dr. Satish Chauhan, your chemistry teacher. In this video 2 of chapter 3, that is manufacture of basic chemicals, you will learn manufacture of sulfuric acid by contact process. Manufacture of sulfuric acid. Sulfuric acid is one of the most important chemicals produced by chemical industry. The progress of chemical industries is measured by the amount of sulfuric acid consumed. Sulfuric acid is used in the manufacture of fertilizers, leather, refining of petroleum, dyeing of fabrics, electro refining process, industrial explosives, textiles and plastics, and so many. The process. The production of sulfuric acid involves following essential steps. Sulfur or pyrites, these are converted into SO2 in the step 1. The step 2 involves conversion of SO2 to SO3, and in step 3 SO3 is converted into H2SO4. Out of these steps, conversion of pyrites to SO2 and conversion of SO3 to H2SO4 are relatively easy. However, conversion of SO2 to SO3 is a difficult step and hence the most important step in the manufacture of sulfuric acid. Sulfuric acid is manufactured by two ways: lead chamber process and by contact process. Let us consider the comparison between lead chamber process and contact process. In lead chamber process, 78% H2SO4 is obtained only. About 90 to 100% H2SO4 is obtained in contact process. It requires further purification of H2SO4. It does not require further purification of H2SO4. After dilution, the required strength of acid is not obtained. After dilution, exact strength of acid can be obtained. It requires further concentration to get 98 to 100% H2SO4. It does not require further concentration. Conversion of SO2 to SO3 is done by mixture of NO and NO2. The conversion of SO2 to SO3 is done by atmospheric oxygen in contact process. Nitrogen oxide acts as a catalyst. Vanadium pentoxide, V2O5 or platinized asbestos act as a catalyst. Nitrosyl sulfuric acid may be formed as an intermediate. No nitrosyl sulfuric acid is formed in this process. It is cheaper and can be handled easily. It is somewhat expensive and requires experts' supervision. Let us consider the manufacture of sulfuric acid by contact process. The contact process for manufacture of sulfuric acid involves following three steps: preparation of SO2 from sulfur or pyrites, conversion of SO2 to SO3 by atmospheric oxygen in the presence of platinized asbestos or V2O5 catalyst, absorption of SO3 by water to form H2SO4. These are the three steps. Let us consider raw materials. The raw material required for contact process is mainly sulfur or metallic sulfide. Iron sulfide such as pyrite FeS2 or pyrrolite Fe7S8 are used. Non-ferrous sulfide such as CuS, PbS, NiS, ZnS may be used. Dry air and steam are also used in the process. Description of the plant and process. The plant is used in the contact process consists of 5 main parts: sulfur or pyrite burners. Sulfur or iron pyrite burner is burnt with the good quality of air to produce sulfur dioxide in the furnace called as burn. Manufacture of sulfuric acid by contact process. Sulfur or iron pyrite FeS is burnt with a good supply of air to produce sulfur dioxide SO2. S plus O2 that gives SO2 plus 297 kilojoules of energy. 4 FeS2 plus 11 O2 that gives twice Fe2O3 plus 8 SO2 plus 3442.4 kilojoules of energy. The traces of SO3 are also formed and give sulfuric acid fog with water vapors present in air. A regulated supply of air passes over the molten sulfur or pyrites, sweeping the products of combustion gently into the next chamber. The percentage of SO2 and O2 in the gas coming from burners is carefully controlled as per catalyst used in the converter. For example, for PT catalyst 10% SO2 and for vanadium catalyst 7 to 8% SO2 is needed. The plant used in contact process consists of 5 main parts: sulfur or pyrite burner. Second is purifying unit, which consists of washing and cooling tower. Second is drying tower, and third is arsenic purifier. So, it consists of 3 subunits. Purifying unit consists of 3 subunits: washing and cooling tower first, second drying tower, and third is arsenic purifier. The next unit is testing box. Fourth unit is contact converter, contact or catalytic converter, and fifth is absorption unit. The traces of sulfur trioxide are also formed to give sulfuric acid fog with water vapors present in the air. So, what is done here? Air and sulfur is present here as iron pyrites, hot air is passed here. So, these are converted into the SO2 plus O2. So, that is impure SO2 O2. This is passed into the dust precipitator, and then it is passed into washing and cooling tower. The water is sprayed from the top. So, waste water is collected from the bottom here. Then gases SO2, it is passed into the drying tower, where the concentrated sulfuric acid is sprayed from the top, and the waste acid is removed from the bottom. The dry SO2 plus O2 is then passed into the arsenic purifier, where arsenic is removed here, A regulated supply of air passes over the molten sulfur or pyrites, sweeping the products of combustion gently into the next chamber. The percentage of SO2 and O2 in the gas coming from burners is carefully controlled as per catalyst used in the converter. For example, platinum catalyst 10% SO2 is needed, and for vanadium catalyst 7 to 8% of SO2 is needed. Then it is passed into the catalyst vanadium pentoxide or catalytic converter. SO2 is converted into the SO3. Then it is passed into the absorption tower. So, where we get here oleum. Purifying unit. When pure sulfur and purified air are used for the production of sulfur dioxide, purification is not essential. However, pyrites contain impurities like arsenic, dust, moisture, and therefore they need purification. Generally, the gases coming out of the numbers contain impurities like dust, arsenic oxide, water vapor, and sulfuric acid fog. They are removed as follows. The gases are first passed through the dust chamber, in which steam jets are introduced from the top, and dust particles with water droplets settle down at the bottom of the dust chamber. Then the gases are passed through cooling pipe to cool them to 100 degrees Celsius. They are then passed through the scrubber. To remove the acid fog. These gases are dried by passing through drying tower packed with pieces of quartz. The concentrated sulfuric acid flows down from the top and absorbs the moisture present in the gases. Finally, these gases are passed through arsenic purifier, where ferric oxide removes the arsenic oxide in the gases. Number 3, testing box. Testing box is a rectangular box darkened from inside. It is also called as Tyndall box. The gases free from dust and H2O3 particles are laid in the testing box. It is viewed through a hole perpendicular to the path of light. A strong beam of light is thrown against the gases. The solid particles, that is impurities, if present, make the path of light visible due to the scattering of light by them. If the gases are still found to contain impurities, they are again passed through the dust chamber, scrubber, drying tower, and arsenic purifier. Only the gases freed from impurities are passed into the contact converter. Contact converter. It is in this part the sulfur dioxide SO2 is oxidized to sulfur trioxide by atmospheric oxygen in the presence of platinized asbestos or V2O5, that is vanadium pentoxide, as a catalyst at 500 to 600 degree Celsius. Twice SO2 plus O2. Temperature is 595 gives twice SO3 plus 196 kilojoules. The catalyst used is vanadium pentoxide. A contact tower consists of an iron converter with iron pieces packed with a catalyst, that is V2O5 or platinized asbestos. The gases free from the dust and As2O3 particles are first passed through a preheater and heated to about 300 degrees Celsius before they are admitted to the contact tower. Heat exchanger and converter. This is the diagram of heat exchanger and converter. As the gases pass through the catalyst pipes, SO2 is converted into SO3. Since the reaction is exothermic, heat produced raises the temperature of gases reaching in the catalyst pipes above 450 degrees Celsius. In the most of modern contact plants, there are two converters. The gases are first passed through one converter at 595 degrees Celsius, where the rate of oxidation is about 80%. The gases are then cooled by means of heat exchanger and then subsequently passed into the second converter at 450 degrees Celsius. Here the rate of conversion is 97%. The exchange of heat takes place between the incoming gases, passing upwards around the catalyst pipes and then reacting the gases in the catalyst pipes. Absorption unit. The sulfur trioxide is released from the converter cannot be directly absorbed in water because it results in the formation of dense sulfuric acid mist due to exothermic reaction. H2 plus SO3 that gives H2SO4 plus 101 kilojoules of energy. Sulfuric acid fog consists of small droplets of sulfuric acid molecules, encloses water molecules as well as sulfur trioxide molecules. These droplets cannot be dissolved in water by any means. So, these are the water droplets which encloses SO2, SO3 droplets into the structure H2SO4 molecule. So, this is a droplet in H2SO4 mist. Role of concentrated H2SO4. To avoid mist formation, the cooled SO3 gas from contact converter is passed into the absorption tower, where it meets to the descending stream of concentrated sulfuric acid, that is 100%. The sulfur trioxide is a steam absorbed by sulfuric acid when oleum or fuming sulfuric acid, that is H2SO4 SO3 is formed. This can be diluted to obtain sulfuric acid of any desired concentration. The rate of absorption of sulfur trioxide is adjusted to get 100% acid at the bottom.